Section 4.4, Solving Systems of Linear Inequalities, the graph of an inequality. Equations in the form ax plus by equals c are straight lines when graphed. If we change the equal sign to any of these signs, we obtain a linear inequality in two variables. A solution of an inequality in two variables, x and y, is an ordered pair of real numbers with the following property. So a solution. The graph of an inequality in two variables is a set of all points whose coordinates satisfy the inequality. A solution is a set of all the points on one side of a line. Now, we have three steps for graphing a linear inequality in two variables. The first one is to graph the boundary line found by replacing the inequality sign with an equal sign. If the inequality sign is greater than or less than, graph a dashed boundary line, indicating that the points on the line are not solutions of the inequality. If the inequality sign is greater than or less than or equal to, graph a solid boundary line, indicating that the points of the line are solutions of the inequality. For the second step, choose a point, not on the boundary line, as a test point. Substitute the coordinates of this test point into the original inequality. And the third and last step is, if a true statement is obtained in step 2, shade the half plane that contains the test point. If the statement is false, you're going to shade the half plane that does not contain the test point. For example 1, it says to graph the inequality for x minus 2y is greater than or equal to 8. So the first thing we need to do is replace the inequality signs with an equal sign, and then we're going to solve this equation to leave it in the form y equals mx plus b. So we have 4x minus 2y equal to 8. We need to isolate y, so we subtract 4x on both sides. Now I have negative 2y equals to negative 4x plus 8. Divide everything by negative 2. So y equals 2, negative divided by negative is a positive, so we have 2x, positive divided by a negative is a negative, negative 4. Now, when we divide by a negative, we flip this sign. So flip the sign when dividing by a negative. Dividing by a negative. So this is going to be y is less than or equal to 2x minus 4. As we can see, this is going to be a solid line. So from here, I know my slope is 2 over 1. And my y-intercept is going to be 0, negative 4. So that's the first thing we graph, 0, negative 4. So 0, negative 4 is right here. And then we count 2 up and 1 to the right, 2 up and 1 to the right, 2 up, 1 to the right. As we said, this is going to be a solid line. So we connect the points. Now the next step is to choose a test point in one side of the half plane. I'm going to choose a point 0, 0, and then we're going to check the point on the original equation. So that's going to be 4 times 0 minus 2 times 0 is greater than or equal to 8. So 4 times 0 is 0 minus 2, so 0 is greater than or equal to negative 8. This is false. Therefore, we're going to shade on the other half plane. So we're going to shade over here. Okay. So again, this is a test point. 0, 0. As we can see in example 2, my inequality is already in the form y equals mx plus b, which is the slope-intercept form. So from here, my slope is 3 over 4, and my y-intercept is going to be 0, 0. So let's go ahead and graph that. So 0, 0 is right here. And then we go 3 up, 1, 2, 3, and 4 to the right, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4. Now, 1, 2, 3, 1, 2, 3, 4, right here. Okay. Now, as we can notice, this symbol is not underlined, which means this is going to be a dashed line. So let's go ahead and do a dashed line to connect those points. So a dashed line. And then we're going to go ahead and choose a test point on one side of the half plane. It doesn't matter where. Let's go ahead and choose 0, 3. So test point 0, 3. We check on the original equation. So we're going to have 3, which is my y. Remember, this is x and this is y. So we have 3 is greater than 3 over 4 times 0. So that's going to leave us with 3 is greater than 3 over 4 times 0 is 0. So is 3 greater than 0? Yes, this is true. Since my statement is true, we're going to shade on the side where that test point is. So we're going to shade over here.